Good morning, everybody. My name is Boelo Schuur, and I'm Scientific Vice President of the European Federation of Chemical Engineering. After being a board member of the Netherlands Process Technologists for 6 years and representing the Netherlands in the General Assembly of the EFCE, I have also served as the Secretary of the EFCE's Working Party on Fluid Separations for 6 years. I have now been in the board of the EFCE since January of this year. I'm a chemical engineer by training, and I've received my degrees from the University of Groningen in the Netherlands, and I built my career in academia. Since 2011, I've been working at the University of Twente, where currently I am a full professor, and my chair is called Sustainable Separation Technology. I'm very happy to introduce this webinar and on how to teach sustainability, and I'm also looking forward to participating in it. A few words on the Spotlight Talk series. This is now our 5th year of the Spotlight Talk initiative, and it started in 2020 during the COVID pandemic. And due to the success of the previous years, we have transformed the Spotlight Talks into a regular feature of the EFCE program. And we now have one Spotlight Talk series in the odd years, where we do have a European Conference on Chemical Engineering. And in the even years, like 2024, we have 2 series, one in the spring and one in the fall. In this fall series, 13 of our working parties and sections, this includes the sustainability section, mixing, electrochemical engineering, high pressure technology, food, loss prevention and safety promotion in the process industries, agglomeration, multi-phase fluid flow, static electricity in industry, education, polymer reaction engineering, and thermodynamics and transport properties, and also early career chemical engineers have been involved in the organization of the short sessions, 3 or 4 talks, focused on very specific topics by leading industrial and academic experts. After this morning session, we still have a few more to come in the coming days, and the complete program is available on the EFCE's website. You can still register for the upcoming events. EFCE promotes scientific collaboration and supports the work of chemical engineers in 30 European countries. We represent over 100,000 chemical engineers in Europe. And the EFCE's working parties and sections cover all major specific aspects of chemical engineering and are the core of our organization. Today we have a special Spotlight Talk series because it's organized by both a section on sustainability and the working party on education. And before concluding, I would like to thank all the people who work hard inside the working parties of the EFCE to make this Spotlight Talk series successful. In particular, Martine Pou from Toulouse, who did most of the conceptual thinking and setting up and practical activities for this and other Spotlight Talks. I thank you for your attention and wish all the speakers and the attendees a fruitful and successful webinar. And I would like to give the word to the chair on the Working Party on Education, Hermann Feise.
Thank you, Boelo. As Boelo said, my name is Hermann Feise. I'm currently the chair of the Working Party of Education. I'll welcome all of you to this morning's Spotlight session, and I thank all the speakers just right from the beginning for agreeing to be here and give their opinion and their knowledge to us. I've also been the president of the EFCE to 2021, I believe, end of 2021. It's a while ago now. And before, I also was one of the predecessors of Boelo as the scientific vice president. Now, as the Working Party of Education, we mainly deal with methods of education and with subjects of education, how to handle new and pressing topics in an already overflowing engineering curriculum. And there was ethics a while ago, and there was digitalization, and today it's sustainability. And I'm very grateful to the speakers who will give us their talk on how to do this without killing the brains of our students. I'll invite Juraj Kosek, who's the chair of the Sustainability Education subgroup in the Sustainability section, to just talk about the new Sustainability Education Initiative.
Mm-hmm. Thank you, Hermann. So my name is Juraj Kosek. I am from University of Chemical Technology in Prague. Welcome everybody to this spotlight talk. First of all, I will mention the new session in EFCE, which is called Sustainability section. You can find the web page of this section. The head or chair of the session is Professor Kosek from Greece and from Imperial College. So he has two affiliations, and you can find a lot of information about the mission of the session in many different aspects on the web page of EFCE, and I will not talk in detail about it. One part of our activities is also how to let's say, address the challenges in education, sustainability, and we are going to cooperate with Working Party on Education with respect to this topic. That means our primary mission will be of this part or section on education, sustainable section, will be which concepts have to be really introduced into the teaching during the education of a new chemical engineers or during the training of already practicing chemical engineers in the practice. And maybe we will address some topics on energy transition, recycling, and other case studies that are linked to sustainability. So that was a brief introduction of the education sustainability section, and I will give a word back to Hermann.
Thank you, Juraj. Before we get started with our first presentation, let me just quickly give a few technical hints. Presentations will be like 20 minutes, 25 minutes, and we'll have a little bit of time for questions afterwards. So if you want to ask a question, you cannot speak. You have to use the question and answers button, usually at the bottom of your screen. Move your mouse if it doesn't show up otherwise. We will be reading them, and Juraj or myself as the moderators will read out your question to the speaker. Afterwards, if we can't manage all the questions to answer, the speakers will go on to the Q&A chat and do answer them individually through the chat. So that said, let me introduce our first speaker, Professor Piero Salatino from the University Federico II in Naples. Piero is there the chair of plant design. I think that's the reasonable English translation. And he also teaches plant design and material technology in the chemical engineering as well as the industrial biotechnology programs. He also had the great pleasure of being the dean for the schools of engineering, later for polytechnics and fundamental design for about a decade. So he knows all about the funs of introducing new subjects into programs. And he will tell us about how to teach sustainability for T-shaped chemical engineers. Now that's a word I would love to learn about, T-shaped chemical engineers, and what the experience in the Italian universities are. Piero, please.
Thank you, Hermann. Let me share the screen and perfect. Can you please confirm me that the presentation is visible?
Yes, it is.
Perfect. Thank you so much. So thank you for the introduction. Actually, Hermann reminded my origin, which is University of Naples, Federico II. Actually, I have the privilege of bringing my contribution to all of you from the role of chairman of GRICU. GRICU is the association of all researchers and teachers who are active in the Italian university system, a gathering of some 400 people who are active in the university systems in all Italian universities, chemical engineering program, an association which is closely interacting with the IDIC, the Italian Association of Chemical Engineering. And before starting, I wish to underline that my talk will mostly reflect my personal views, although they are quite naturally inspired by my role and by the frequent interactions with colleagues in GRICU and outside GRICU. Let's start from T-shaped. Well, the T-shaped cultural paradigm has been quite popular over the years, as it represents a virtuous combination of two components. The vertical bar of T represents the depth of competencies in the native, in the core field of the professional, whereas the horizontal bar represents the ability to cooperate across disciplines. We might say that the length of the I bar, the vertical, and the horizontal bar is a measure of how the two components of professional competencies are balanced with each other. Introducing transversal and core field when applied to chemical engineering immediately brings up the epistemological question. Where is core chemical engineering? How can we locate core chemical engineering? No doubt, chemical engineering is unique. It is the only engineering field which deals with molecules and molecular transformation at its core. And as such, chemical engineering is an area of intellectual inquiry and commercial application that is profoundly important for society's future advances in energy, food, water, medicine, and manufacturing. And the peculiar feature of chemical engineers to deal with both molecules and the enormous industrial plants that produce them make them unique in encompassing a large range of length and time scales. We may state that more than a dozen orders of magnitude in both length and time scales are covered by chemical engineering education. And this has been the hell and heaven of chemical engineering at the same time, the key to the success of more than a century, as it focuses the analysis of linked processes regardless of scale. This concept has been further expanded by James Way in a very interesting paper published in Chemical Engineering Science in 2007, where James addressed the problem of how to orchestrate chemical engineering skills in multi-scale contexts. The typical way is developing models and approaches at different scales, from the atomistic molecular models, going up to mesoscopic models, engineering design models, ending up with the systems engineering models. Where is core chemical engineering? Let me state that I will mostly address chemical engineering education at the Masters of Science level, which is the most popular in Italy. Almost 95% of chemical engineers in Italy hold a Masters of Science degree. And this is, broadly speaking, where core chemical engineering is located, embracing mesoscopic models and engineering design models with some openings to atomistic molecular models and very limited openings to systems engineering. Is the chemical engineer a specialist or a generalist? Chemical engineering education has historically combined competence at the molecular scale with competencies at the equipment scale, a very successful combination that is still here today. That is why chemical engineering curricula entail more required disciplines than any other engineering curriculum. So chemical engineers are inherently interdisciplinary, even at the core level. But interestingly enough, my perception, which is shared by many colleagues, is that chemical engineers are more frequently perceived as specialists, possibly due to their ability to target the many facets of their culture on very specific accomplishments. The widespread perception of chemical engineers as specialists in comparison with other professionals may be a risk. It may hamper full appreciation of the breadth of our culture and of the potential impact of our community on society, especially at the systems engineering level where decisions are made. This is something we have to take into account in further development of chemical engineering education. It's quite clear that chemical engineering cannot be aimed at generating one-man bands, spanning the entire spectrum of scales and approaches, but rather it should aim at developing open-minded professionals which are able to build up their own identity and profile, to interact with other chemical engineers and with other professionals, sharing goals, abilities, and methodologies. And that the chemical engineering as a whole should undertake the responsibility to develop and orchestrate the many competencies that are needed to meet societal demands. The combination of core plus electives may be accomplished by grafting of other disciplines and scales onto core chemical engineering education, which may be done on an individual basis. And this may be the key to the richness, breadth, and the biodiversity of our community while preserving its identity. And the starting point must be a robust core education, which must be rooted in the fundamentals, which might provide enough docking sites for grafting of elective components. Let's come to sustainability. Sustainability has always been present in chemical engineering education, mostly in relation to the prevention, mitigation, remediation of environmental impact of process industries, as well as judicious utilization of resources. But I want to take this opportunity to launch the appeal, which comes from Roland Clift, a distinguished chemical engineer who is active in IChemE and other associations. What tells us is why is so much of engineering devoted to finding more efficient ways to do things that should not be done? The engineering professions, who have been one of the main enablers of industrialization, now need to step up and take on their responsibility for correcting the potentially disastrous consequences of industrialization. This is an ethical imperative that goes beyond the imperative to practice our art responsibly. So Roland Clift calls us to a broader perspective to get the big picture, and this is a message that we have taken in our into account in tailoring our chemical engineering programs. Italian chemical engineering education has always kept the pace with emerging sustainability issues. There are many established and ongoing innovation in educational pathways in all the universities spread all around Italy. Study programs are most typically easily tailored to the careers of students who are willing to develop expertise and the competencies in sustainability. The way this is accomplished is mostly by providing either dedicated curricula or single electives that can be easily grafted onto the core chemical engineering curriculum. And this is done most typically at the Masters of Science, that is the Laurea Magistrale level, where the maturity of the professional after the Bachelor of Science, the Laurea, may be assumed to be complete. What have been the paths for embedding sustainability and chemical engineering? Most sustainability-oriented education falls within the classical domain of core chemical engineering. Nevertheless, there are some remarkable attempts to follow, let me say, Roland Clift's appeal to broaden the scope of education beyond the limits of traditional chemical engineering. I want to underline how systems engineering has been empowered by an increasing engagement of chemical engineers in industrial ecology and awareness and utilization of its tools, namely life cycle assessment and material flows accounting. On the other hand, moving to the microscopic level, the sustainable by design paradigm, which is more extensively pursued in chemical engineering schools and departments, has been further sustained through deeper engagement of chemical engineers in molecular, biological, and formulation sciences. The way this has been done, as I mentioned before, has been by developing, in many cases, dedicated programs, curricula. This is a not comprehensive, but rather extensive survey of curricula in chemical engineering that are specifically active on the topics of sustainability. We have a chemical engineering program in Naples with a dedicated curriculum on sustainable chemical engineering. We have a fully dedicated curriculum in Politecnico di Torino, a dedicated curriculum within the chemical and process engineering program in Bologna, similar choice in Palermo, in Salerno, and in L'Aquila. In Catania, we have a fully dedicated program in the Masters of Science on Chemical Engineering for Industrial Sustainability, and similarly at the Roma campus, Biomedico. In Trieste, we don't have a chemical engineering program, but a joint materials and chemical engineering, which is fully devoted to sustainability from both the perspectives of nano-bio and sustainable approaches. These are dedicated programs. There is in all the programs throughout Italy, there is a wide choice of electives. In this word cloud, I have just summarized a few recurrent topics, a few recurrent disciplines. You may appreciate our industrial ecology is getting more and more diffused in chemical engineering programs as a response to the willingness to open up the perspectives of chemical engineering beyond the lab, beyond the chemical plant. There are many sustainable design, green engineering, green chemistry processes. There are emerging tendencies also to host electives that come from the societal, economic, human side of our universities as business models for sustainability, or other courses which deal with the societal impact of sustainability and industrial operations. I want to conclude my talk by mentioning a quite important, a good practice, a pilot initiative, which has been undertaken jointly by several universities, which is the minor in green technologies. The minor followed the model of minors versus major, which is quite recurrent in the Anglo-Saxon university system. The objective was to try to develop professionals with a more pronounced systemic approach, with an interdisciplinary vision, with better digital abilities, attentive to innovation, ready to face the transformations of the ecological transition. This has been accomplished by developing a module of 30 credits. CFU is the university credit in Italy, which stands for the ECTS in the European standards. This module embodies basically three components. First, cross-sectorial sustainability-oriented technical scientific studies, which is almost half, slightly more than half of the module. Then training activities for the promotion and the improvement of digital skills, essentially artificial intelligence and the data analysis. And finally, training activities in the legal, regulatory, economic, and societal and managerial culture contexts. This third area is mostly covered by seminars rather than courses. And the key is keeping together in the very same class students from different origin: chemical engineering, electrical engineering, energy and nuclear engineering, mechanical engineering, environmental engineering, materials science and engineering. Those are the programs which are involved in this experimentation, and those are the students who are entitled to participate in this program. Where is this experience active? The pilot initiative has been started as part of a broader project, Technologies for Transitions, which was stimulated by the Ministry of the University and Research, and which was started by a consortium of big engineering schools: Politecnico di Bari, Politecnico di Milano, di Torino, University of Bologna, of Napoli Federico II, of Padova, of Palermo, and the University of Rome. Where is the minor located? It may be either embedded in the final term of the Masters of Science programs. Alternatively, it may be used to bridge multiple Masters of Science programs for students willing to get a double degree. Or a further option is to take the minor as a standalone module for continuing education programs. The minor is no official recognition from the governmental university system, but there is a recognition of micro-credentials through an open badge, by awarding an open badge to the participants. This is just to show you how the minor may be used. It is a flexible building block to set up flexible educational paths, starting from the traditional path of the Masters of Science, Laurea Magistrale programs, which consists most typically of 4 terms of 30 credits each, for an overall coverage of 120 credits. The typical typical implementation of the minor is embedding it into a classical chemical engineering Masters of Science. There is the requirement that only part of the 30 credits of the minor may be recognized within the Masters of Science program. There are some excess credits, most typically 10 to 15, which are additional to the program. But there are, as you see in this slide, also other ways the minor may be employed in building up flexible higher education programs. The example that is reported here is having the minor as a bridge, as a link between a chemical engineering program and other chemical engineering programs. This has been experienced, for instance, at Politecnico di Torino, by getting double degrees which combine chemical engineering with either energy engineering or environmental engineering. And the further opportunity, which we will foresee in the future, is to make those minors available to any professional in a continuing education program in order to keep up to date with the latest achievements in the sustainability science. And with this slide, I would like to conclude my talk, and I would like to thank you for your attention. I will be ready to ask your question and to give any further details on our activities in Italy. Thank you so much.
Thank you, Piero. You made excellent time. You were even 2 minutes before me, so welcome there. To the audience, please be invited to put your questions into the Q&A chat box, and Juraj will watch that and make sure we don't miss out of that. Now, Piero, what we're explaining with the minor was that the student will actually have to do extra work on it.
Exactly.
Right. So
not too much indeed, because from 1/3 to half of the minor, it is extra credits with respect to the minimum required for getting a Masters of Science. It is recognized in the curriculum. If you go you have a list of all the credits that you have achieved. So it's not truly beyond the borderline of the Masters of Science. It is within the borderline, but it is an extra effort that we require to our students. It's quite successful. Students are quite often willing to pay this extra penalty, let me say, in terms of education, because they recognize that this extra effort is well paid back in terms of a broadening up their vision. The interaction with other students from other disciplines is quite stimulating. It is one key, of course, to achieve a full interdisciplinarity. They have to interact. You have quite typically team working, which is part of the education, and it's nice to see chemical engineers side by side with mechanical engineers, environmental engineers, sharing their language, sharing their approach, and trying to develop a common approach to the problems. This is the 3rd year of experimentation, not too much indeed, but so far so good. We are planning to further expand this type of measure. And I have to say that the minor in green technologies has been inspiring in the university systems also for other initiatives. there is now a flourishing of other minors in other sectors. So we pioneered to some extent this kind of experience.
Okay, you said it's a prototype pilot project. Do you have a plan of like rolling this out to all engineering universities, or is this completely voluntary? Every university does what they want.
To be honest, when it was stimulated at the very beginning, it was stimulated by an input from the minister for university and the research, who, by the way, was my former rector, Professor Manfredi. He was willing to push this further by providing also financial support to this kind of experimentation. Unfortunately, this was not pursued any further. So right now it is undertaken on a voluntary basis. It is self-funded by the participating universities, but the success of this experiment, of this pilot experience, is such that I'm quite optimistic under this respect. I think there might be a way. There might be a way to further exploit this experimentation. There has been an immediate fallout of this at the institutional level. From last year, we have introduced in Italy the National Erasmus program in order to facilitate exchanges within Italy, which is a kind of, let me say, a scaling down of the Erasmus project within the... And this was stimulated actually by the discussion on the minor, because one of the provisions of the minor was to facilitate exchanges of students among the engineering schools who were participating in this project. So this is the first step. Possibly there will be others.
We do have questions in the chat, so I'd like to read them out, and I'll take the second one first. Simao Pino writes, a relevant aspect of sustainability is related to social sciences as economics, management, these kind of things. And how is that integrated in the new courses?
In the minor, we have a specific section. It is not that large, to be honest. We have between 5 and 6 credits, which are dedicated to making our students aware of the economic and societal implications of, let me say, chemical engineering in the sustainability, in the realm of sustainability. It is mostly a way to make them aware, to stimulate further studies. We don't have to forget that we are dealing with the Masters of Science, those willing to further implement their culture have the opportunity to make further steps in that direction. But it has been a small step, but a very important step, because before that minor, there was very limited presence of any topic outside the technical scientific area in our Masters of Science program. As you have mentioned, keeping an eye on societal and economics is absolutely essential, at least to develop a sensitivity to this. And then you can, of course, implement by...
Yeah, there is a similar question from Naila, even from Toulouse. And she says, he says, you haven't mentioned biological sciences or ecology, but it seems that these fundamentals are required to have an understanding of ecological sciences.
It is. To be honest, we have considerably broadened up the contributions from biology, biochemistry, synthetic biology, and the contribution of ecology is still extremely limited in our programs, if not absent. If it is, let me say, embodied in the broader, I realize industrial ecology and ecology are not the same. They have different approaches, but they, to some extent, the awareness of the ecological implications of chemical engineering are to some extent considered in the frame of life cycle assessment and in the broader frame of assessment of processes and products according to the tools of industrial ecology. This is what we have done so far. But again, we have to remember that the time of a student is limited. The effort he can dedicate is limited. We cannot generate a one-man band. This was the very core of my talk. I don't know whether it was appreciated. We cannot pile up and fill our students with many. What we can do is to provide docking sites. Okay, we can provide docking. It's like enzymes. We can possibly generate docking sites, and then we can attach pieces of competencies and methodological aspects in an individual person-to-person based approach. Each of us has to have its own chemical engineering genome. This is my personal view, which is shared by many. Each of us has to have a feeling of being part of a community, but also a feeling of being unique in this community. And this is clearly one key to the current trends of chemical engineering education in Italy.
Yeah, thank you. We've got time for one more question, and it's about is there any experience to be shared in integrating digital transformation into sustainability education?
We are doing this not systematically, but we are doing it. This has been favored also by some initiatives at the governmental level. For instance, we have a national doctoral program on data science and artificial intelligence, which is promoting pretty much interaction among disciplines. Chemical engineering is taking the center stage in this process, as we are taking advantage of interaction with IA native competent people. I have to say it's booming. The presence of AI is booming in our curricula, and it is booming in many cases with specific reference to sustainability issues under many respects, in many ways and under many respects.
Right. Thank you, Piero. Thank you for your presentation and for answering all those questions. If people have more questions, please put them in. Piero will see them in the Q&A session and be able to answer them.
Thank you so much. Thank you so much.
Thank you. Our second presenter of today will be Sarah Hitt. Sarah is from the north of the island. She works with the Engineering Professors Council in the UK and the New Model Institute of Technology and Engineering. I don't know where those are located, but she's also a visiting professor at the Edinburgh Napier University, and that's what I do know. She's been very active in pulling things like humanities and art, tools and ideas into engineering education to integrate sustainability, ethics, communications, all these not so typically engineering type subjects that modern engineers need to grasp into the field. And she'll be giving us an idea of the sustainability toolkit that was developed during the project with the Engineering Professors Council. Sarah, please.
Thank you. Thank you, Hermann. Thank you, Juraj and Martin, and for everyone for having me speak to you today. I am excited to share with you a resource, the Sustainability Toolkit, that was published earlier this year by the Engineering Professors Council. And the Engineering Professors Council is the representative body of engineering academics in the UK. So it acts as a voice for all those working in engineering education in terms of policy, in terms of events and networking, and also in terms of resources. What we have found at the EPC is that engineering educators, well, as we know, and as was mentioned by Hermann at the start of this, we're all very busy and we have a lot of pressures. And so one of the things the EPC has been trying to look at is how can we as an organization provide resources and support that can make everybody's jobs a little bit easier and make people feel connected to others who are doing similar work. So one of those resources is the Sustainability Toolkit, which was developed with the support of the Royal Academy of Engineering and Siemens. This is an open source, free to use online resource. I'm going to tell you a little bit today about sort of what motivated us to create this resource and sort of why we believe it is needed and useful and can have an impact. This is an action-oriented, practical tool that can support people to do some of the things that Piero was mentioning too, that breadth of educational content and competency development, but in a very practical and efficient way. And then I'm going to talk about how it was created. It was a co-created, community-sourced project. And I'm going to sort of give an example of some of the tools that are available for everyone to use, and then show some use cases that I think are particularly relevant to chemical engineers and chemical engineering. I should also say that you can access I'll give a QR code and a link in a moment, but I have found that when you search any browser for sustainability toolkit, and then sometimes if you add engineering, but even just sustainability toolkit, it usually comes up near the top of sort of after sponsored links. So hopefully through these methods you can search along as I'm speaking. In any case, obviously, as we know, we're looking at some pretty major global risks ahead. And it's interesting to look at, this was the 2-year prediction from the World Economic Forum, which is almost 2 years ago now, sort of saying, what are we going to be needing to be looking at in terms of the world, in terms of policy, engineering, governance? And so what do we therefore need to be preparing our students to undertake, or at least demonstrating to students that they are working in a world in which this is the context for their work? We also know that industry has, in industry response to the climate crisis and all of these other global risks, industry is starting to put forward sustainability strategy and sustainability initiatives. However, at least in the UK, and I know this is not unique to the UK, many companies are saying, we have the sustainability strategy, but we don't necessarily have the people who have the skills to enact those strategies. So the engineering skills shortages around sustainability are really quite profound. The other motivation for the development of this resource was students themselves. So 30% of students that were surveyed in 2023 said that 30% had covered the UN Sustainability Development Goals, yet nearly 60% said that they wanted to be engaged with projects related to those SDGs. We also have done some engagement with different groups of people in engineering, so educators, professionals, students at various events over the past couple of years, and asking them, did your degree prepare you to act sustainably and equitably? What I am heartened by in this is that students are saying more that they were prepared than perhaps some professionals or educators. So perhaps this picture is shifting, and I hope that it is. But of course, it means that we have more work to do in terms of engineering education to prepare students to be able to act. And this is also very important. It's not just the knowledge, it's not just the technical skills. It's do you have the competency and the ability to act sustainably? However, importantly to this, the development of these competencies really is dependent on different ways of thinking and teaching. If we're trying to prepare students for different ways of knowing and doing and being, it means we have to educate in different ways. And that's a tough call, because that comes back to educators ourselves. So our goal is to support those educators, as we have mentioned already today, that maybe we ourselves aren't feeling as educators as if we had the preparation to teach students. even if we are motivated to teach sustainability or to integrate this into our modules or our programs, it doesn't necessarily mean that we were taught how to do that. And then suddenly these external demands are saying, we need to. I was just at another engineering education conference in Tallinn in September about engineering education. And these were some of the examples of the talks. Are the engineering professors prepared? And what can we do together in order to help ourselves and support each other through things like a community of practice? So we were really motivated at the EPC by this and by our partners in creating the toolkit. Ensuring that teaching practice is really fit for the world in the future is the means by which we're going to prepare those future engineering practitioners to respond to those global risk challenges. So essentially, our goals with the sustainability toolkit are to do 4 things. We want to amplify the work of people who are already really making promising steps in these directions of sustainability and engineering education, because we know that there is a lot of excellent work going on out there. We also want to really reassure every engineering educator that they don't need to reinvent the wheel. There are resources out there that you can access, and we want to complement those. 2, we want to fill gaps by providing things that might not exist. There's a lot on sustainability and sustainability competence, but perhaps that doesn't translate neatly or easily into the engineering education context. And so we wanted to develop some resources that could do that. And of course, as I said before, all of these changes are dependent on people, and people need support from other people. And so we really wanted to connect those who are working in this area, because what we have seen is that universities tend to be on this sort of spectrum, from a more ad hoc approach where sustainability and ethics are kind of scattered here and there around programs, but perhaps not very coherently, all the way through sort of added on. We'll tack on a module or add a capstone, but it's still separate. It's not threaded through in an integrated way across an entire curriculum. And of course, what we really want is to be helping everybody get to this stage that sustainability is really woven through everything that we do. And I think we're moving in that direction, but we wanted the toolkit to be a resource to help people get there. Of course, this is all within a context of a lot of excellent work that already exists in terms of resources for integrating sustainability. That ranges from obviously our accreditation standards, which in the the UK are from AHEP and the Engineering Council. There's also education for sustainable development guidance. Organizations, industry like Siemens, different companies also have sustainability networks. The EU has the European Sustainability Competence Framework. And then there are the resources such as Engineering for One Planet, which has sustainability-focused learning outcomes for engineering. That was published late in 2022 with lots of teaching resources and activities. And then the Engineers Without Borders UK Reimagined Degree Map, which is a resource to help programs and leaders and educators kind of rethink the way that degrees work. So it's a lot. It's a lot to distill and digest. And as I've said before, we're busy. We don't have a lot of time. So what we wanted to do was to provide a resource that could distill this very quickly and easily explain these sorts of movements and opportunities that exist, so that you as an engineering educator can translate this into your practice tomorrow, if your teaching practice, if you wanted to. So we worked with a lot of partners on this project, as I said, supported by the Royal Academy of Engineering in the UK and Siemens, but really developed with dozens of contributors across education, industry, and advocacy organizations from 4 continents. We had input even from students, which was really, really wonderful. And there you can see the link to the toolkit and to some of our other partners who really helped to inform the project. So what is it? What does the toolkit consist of? We found, we did some stakeholder engagement to see, well, what do educators want? What do they need? So when you are you have this desire to integrate sustainability, perhaps at the very first step, you might need to improve your own knowledge around, what does sustainability competence mean? How does that relate to engineering specifically? So building up your own knowledge. And of course, there are wonderful journal articles, publications that detail this in depth. But oftentimes you need, 500 words that then can point you to other more detailed information. And so that's what our knowledge tools do. Then you might be wondering, okay, I know what I need to do, but how do I actually do that? So we've provided a suite of resources that are guidance tools. So these could be anything from how to integrate sustainability in a project, or how to assess those sustainability competencies once they have been integrated. How do you design a new module or redesign a module so that sustainability is embedded throughout? So those guidances are really step-by-step processes. Then sort of the biggest component of the toolkit are teaching resources. And these teaching resources, as I've said, are meant to be very action-oriented so that you could implement them in your modules with very little effort. So the idea is that they are lesson plans, activities, teaching activities, project briefs, pedagogical case studies. And the beauty of these tools is we've designed them to be very flexible and adaptable so that you could use a portion of one. You could add on other parts, components to it. They have plain text and PDF downloads so that you can copy and paste into your virtual learning environment or into your PowerPoint slides. So they're really designed as teaching tools to help educators sort of know how and what to integrate and implement. And finally, we are really trying to provide resources that, as I've said before, can connect people with each other, learn about the good work that other people are doing. So what I'm going to go on to do now is talk about some examples of these. But first, I'm going to talk about some of the features. So I've mentioned that the tools are flexible and adaptable, but we've also created a way for those tools to all be searchable in an easy way and then mapped to the kinds of things that educators often need to demonstrate as a result of implementing sustainability. So we have a search feature. This is an image of the search feature. You will see with this search feature that we have other toolkits with the EPC. The other one that I was involved in working on was the engineering ethics toolkit. So that is another resource that has fantastic links to this topic. And in fact, some of the resources are cross-posted, because we do know that there's an overlap between sustainability and ethics. We are in the process of developing a complex systems toolkit. So again, Piero was mentioning that stretch into the systems engineering arena and the need to be thinking in a systemic way. And so that toolkit is going to be starting development early next year. But there are more. So you can search all of the toolkits or just the sustainability toolkit. You can put in keywords, active learning, a specific systems thinking, for example. Your discipline, you could put chemical engineering and see what you find. All of the tools are also, they're kind of keyword mapped so that maybe you need to show that you are teaching a certain sustainability competence, as identified by UNESCO. Perhaps your program is one that demonstrates where and which SDGs are being taught in the curriculum. So those are evidenced. We talk about, because this is a UK-based resource, we map to our accreditation standard, but through that, you could also see how these resources could be mapped to or aligned to other accreditation standards. And then each one shows which sort of intervention for transformative sustainability learning is being developed in the resource. And I'll explain what that means in a moment. As I mentioned, another feature of the toolkit resources is they are linked to parallel initiatives. And I mentioned Engineering for One Planet, which is an initiative out of the US. It's wonderful. It has suggestions about learning outcomes, about integrating sustainability, and an activity guide. EOP has also provided a resource to the toolkit, which maps their learning outcomes to the UK accreditation. So we're really trying to work together. In the Reimagined Degree Map from EWB UK, as I mentioned, they sort of present different interventions for impact. And those are those transformative interventions, such as changing learning outcomes, integrating more real-world complexity, active pedagogies, mindset development, maximizing cross-disciplinarity, which is something we've already discussed today, and then ensuring authentic assessment. They also reference the toolkit in this Reimagined Degree Map, and each one of our resources shows which of those interventions each tool is trying to support. One final sort of feature before I describe some of the tools in depth is that we have a resources library. We know our toolkit is not comprehensive by any means, and we know that there is a lot of good stuff out there that, with the best will in the world, we just haven't found yet. So we're always adding to this resources library. We've sorted them. These are other open source online resources on engineering education for sustainability. And so you can find those as well. At the end of this presentation, I will explain how you can share those and get involved if you like. So I wanted to spend just a few minutes talking about how the Sustainability Toolkit resources, a few in particular, can be particularly relevant, I think, within chemical engineering. We had some wonderful members of our advisory group who are chemical engineers, process engineers, manufacturing engineers, sort of working in your area, who both solicited and contributed to these resources. And I should say a little bit about how these resources were created. So we had an open call for contributions, and as I mentioned, people from all over the world sort of submitted. Maybe it was a brand new resource or activity or something that they had already been working on, and then it was reviewed by a body of peers and sent back and forth and then formatted into our style. So we really try to have a robust process of producing really good materials. But again, this is created by us, engineering educators for us. So people who really understand what it's like to stand there in front of the classroom and be trying to have an engaging, meaningful, and impactful experience. So when you reach the front page of the Sustainability Toolkit, of course, you can click on either the different type of tool that you're interested in, or when you scroll to the bottom, you'll see little tiles that will kind of suggest things to you. And so you can navigate around the toolkit in that way. This is a guidance resource that I think is useful to everybody. But this is, for example, a workflow. This was developed by, I think Jarka is on the call today. So a chemical engineer and then an architectural technologist engineer, and sort of showing through a workflow diagram, a process diagram, which I think is great for engineers to sort of follow. How do you integrate the SDGs across your modules or your programs in a really constructively aligned way? And so you'll see at the beginning of each tool, it sort of gives you the topic, what the tool is about, and why. Why is this tool needed? What you can do with it. There are also hyperlinks throughout each tool. You can click right to that workflow diagram or to that constructive alignment tool. So that's a good one if you're kind of thinking about, I need some guidance to help me plan for this in order to do this really intentionally. Another example is if you might want to be using a pedagogical case study. And what I mean by a pedagogical case study is sort of, rather than just kind of describing what happened in a certain case, how can you use a case to teach? So this particular example is about hydrogen fuel and aviation. And you'll see in this case, all of the case studies or all the teaching resources also include educational aim and suggested educational level, and then provides you with learning and teaching notes that you can use as you prepare to use the resource. Those teaching resources may also include things like learning outcomes or objectives, pre-reading suggestions, links to related activities, suggestions that you can use. You could, as I mentioned before, additional steps to add breadth or depth, and then a gesture towards other integrated interdisciplinary approaches. Another one probably dear to this audience's heart is integrating and assessing sustainability in design capstone in chemical engineering. So we do have some discipline-specific examples. So I wanted to make sure to highlight this one. So this is sort of telling you how you can integrate sustainability in your project module. Of course, evidencing sustainability competence and assessment is always the million-dollar question. How do we do that? So this resource sort of suggests what is out there that tells us how that can be done. As I mentioned, each resource also points to other useful resources. So you can go as far as you want in sort of following the chain. So to wrap up, I wanted to talk a little bit about how you can get involved with the toolkit. I mean, obviously, the main thing is I hope that you use it. We hear from people, I'm sometimes surprised at conferences, completely not expecting it. Someone said, oh, you're the toolkit person. I just used a resource and here's how it worked for me. I love that. So I want you to use it, and I want you to tell me how you use it. We publish blogs from educators that describe how they use it, and then those become examples for others. Here's how I did it with a large lecture section. Here's how I did it with tens of thousands of all of my first year engineering students. Here's how I did it across a whole year, all online. Those kinds of things. You can find all of those resources, but you can also contribute. You can suggest resources and further support us. So thank you.
Thank you, Sarah, for a really interesting presentation with a lot of, how do you say, ideas generated, at least in my mind. So good. I have two pictures on the screen. So Juraj and Piero, a question from you?
Yes, maybe this is right. I really appreciate this presentation, especially the practical examples of some of the tools. They were great. And maybe from my side, I know in your career that you were also involved in ethics for sustainability. And of course, we as professional engineers are always trying to avoid something like being too alarming or being up to have some unintentional bias to greenwashing and these strategies that even we see in some public space. So do you have some tools or some practice how to like show the students the examples of unintentional, like these non-ethical activities that are associated with sustainability?
Yeah, that's a great question. And so I will say so the ethics toolkit and sustainability toolkit have a lot of examples of, especially in the case studies, of sort of they put you in the first person position of the engineer who is trying to do something ethically or sustainably, and then gosh, something happens just like what you described. This didn't go as I planned, or that I wasn't expecting that, and sort of helping students think through how to deal with that. We don't have a specific piece of guidance on avoiding greenwashing, and I would love to have one. So if anyone would like to work on that, we would love to add that in. I should say too, yes, this is a living resource, and we are always welcome. We could only do so much in one round of effort. So this is a great idea, and I would like to bring something like that in.
Maybe I have also a second question that would be, your audience is mainly for teaching education at universities, but part of our engineering audience can be also practicing engineers, and maybe
Yes.
they can be interested because they are asked to calculate what is the carbon footprint of that product per 1 kilogram, or some of these like practical problems they are facing. Do you plan to extend your activities also for these practicing
Yes.
engineers?
So it's not within our plan per se, because our scope is engineering higher education. However, I just last week was speaking to the CEO of a company here in the UK. I was talking at I was doing a panel discussion at the Hazards Forum here in the UK, and a CEO of a company there came up to me afterwards and said, I want to use these case studies in my with my new hires as a way to sort of help them kind of engage with some of the problems not problems, but issues that might emerge. So while it's not in our plan, I know that there are cases where that is happening in industry as well.
Thank you.
Thank you. Piero?
Yes, Sarah, thank you so much. Congratulations. I didn't know of the availability of this toolkit, and I will look with great attention. You mentioned at some point peer review, which is quite a critical aspect. We were mentioning greenwashing. Even beyond greenwashing, there are some processes or some activities that are quite disputable, quite controversial. I may personally mention, for instance, direct air capture, which is the source of a big debate. I was wondering, how do you manage peer review? How trustable do you believe from this standpoint?
Well, I mean, I would say we do our best. I mean, when people want to contribute a resource, we seek other experts in that particular field. So, for instance, I'm thinking of a resource that came in about manufacturing and sustainability, and so we really then sought other experts who could sort of say, does this align, or if there is a dispute about it, how could the resource be framed to show that there's not just one way to think about things. I mean, I think part of the point of some of the resources is to show students that there is dispute around things, and we have to be able to critically question. So, for example, there's a series of resources that have to do with sustainability in the built environment, and some of the new there's been a lot of controversy in the UK for whatever reason around heat pumps, and our heat pumps, do they work, and what does it do, and are all of this sort of kind of greenwashing or fake news. And so one of the things that we try to do in the resource is talk about that critical literacy around, well, how do you evaluate these different claims, and what are ways in which you as an educator can can present that to students and help them work through it instead of just saying, this is how it is, and here's what you should do. So I think we try to adhere to the same sort of review standards for educational resources as would be adopted by a journal. But we also try to do that, to show that in a learning way. How can we show students that we're all learning about these new technologies as they emerge?
Thank you, Sarah. We have a minute, so if anybody wants to quickly type a question into the Q&A, we'll read it. If nothing happening there, so I'll say thank you again, Sarah, for very inspiring talk. And yep, you'll have some new followers on that website from today. And I'll give the word to Juraj to introduce our third speaker then.
So thank you, Hermann. So our third speaker today is going to be Professor Schuur. First of all, congratulations to your promotion to a full professor degree that happened, I believe, last week. And you will talk today about transition technologies to third cycle students and industrial engineers. So the audience is yours.
Thank you very much, Juraj. Yes, indeed. I was promoted full professor 1 year ago, and last week I gave my inaugural lecture. I will try to share my screen.
Yes, now we can see it.
And now also in full screen mode, I hope?
Yes, it's in full screen mode, yes.
Okay, so thank you very much, Hermann and Juraj, for asking me to participate here. My presentation is about teaching transition technologies to third cycle students and industrial engineers. Maybe for people who are not aware, we have in the Bologna Agreement, the first and the second cycle are the bachelor and the master, and the third cycle are PhD students. In Netherlands, we also have engineering doctorates. On my screen are a lot of logos, the University of Twente and the Sustainable Process Technology Group. That is where I spend most of my time. But I also work 1 day a week at the Institute for Sustainable Process Technology. That's an institute in the center of the Netherlands, in Amersfoort. And this is a organization where companies and knowledge institutes come together. This is the process technology hub in the Netherlands. And we develop projects where we let PhD students and also industrial engineers work on greening the chemical industry to make new developments towards a more sustainable chemical industry. Of course, also the logo of the EFCE, and left is the NPT, the Netherlands Process Technologists. That is the Dutch member organization, and the Netherlands Process Technologist is partly embedded in KIVI, the Royal Engineers Association of the Netherlands, and partly in the Royal Chemistry Association. So these are the two mother organizations of the NPT that are a member of the EFCE. So with that introduction to all the parties that are important for what I want to tell, I will first look a bit into the transition. And we have agreed as a society in the Paris Agreement that we would like to go to net zero CO2 emissions in 2050. And on the track to 2050, we would have 90% reduced emissions in 2040 and 55% already in 2030. Now, of course, it's questionable whether we will make that or not, but let us aim at the 2050. And an important aspect is if we want to reach this goal, and next to the interim goals that we have formulated here by politicians, I think we should also formulate interim goals for engineers. And interim goals for engineers means that if you want to be net zero here in 2050, the technologies to be net zero, they need already be ready in 2040, because then you still have 10 years to implement them. And in 2030, we need to know which are the technologies. This is only 5 years and a little bit ahead of us. So we do not have a lot of time. And there is one other engineering aspect. If we look at what we are doing, we do a lot of mining for batteries. And so even if we are going to recycle for 90% all the metals that are used in our batteries and in our electronics, by 2040, we would need a 3 times more mining of metals than currently. So this shows that not recycling is seriously not an option. And the only way forward is to do recycling. All right, these are aspects of the energy and materials transition that I think are very important and are key, and they show us that we need to act now and in the coming years to be prepared for this. So, what is my talk about? First of all, before talking about the third cycle, I would also like to take the opportunity to talk a bit about the first and the second cycles in the education at the University of Twente. And then I hope to convince you that there's not so much time. Also, in the previous presentation, it was already mentioned, our curricula are full, and there is not so much time also for teaching. So we need to really consider what do we want to teach and how can we embed sustainability in there. Now, let me give a flavor of the Twente program. We have a 3-year bachelor in Twente, and we divide every year in 4 blocks of 10 weeks. So we have a dense year. We start on the 1st of September. That is the opening of the academic year. And in the beginning of July is the end of our year. So we teach 40 weeks per year. And the 40 weeks are split into 4 blocks of 10 weeks. And we have a materials and molecules and materials track, and we have a process engineering track. And in the bachelor, all our students get a flavor of both the molecules and of the process engineering. And the process engineering modules, they are 2, 5, and 8. Of course, also 6. But I highlight the 2, the 5, and the 8 because these are consecutive modules. In module 2, they learn to work on a mass balance, and they learn the basics of distillation. And they learn what it is to implement a recycle. And basically, the very first steps into process engineering. Then in module 5, I come in as a teacher on industrial processes, and following up is the elective module 11 on process design. In parallel, there is also a module 8 on material science, and these are basically the last modules in the second year. And in the third year, we have the modules 9 and 10. These are electives, minor, and in modules 11 and 12, they do the bachelor assignment. Okay, but let us zoom into industrial processes. That is my own module. Of course, in all the other modules, we talk about sustainability, and we ask the teachers to highlight things related to sustainability and towards future practice. For example, electrochemistry is involved in module 4, and we have electrochemical processes that are highlighted. But zooming in on module 5, industrial processes, we have a 15 ECTS block. Of course, 4 times 15 is 60. That's a full year. And we divide that here into 5 courses. And personally, I am involved in 2 of these 5 courses. And these are industrial chemistry and processes. That's a 4 EC course. And a project on sustainable industrial chemistry. That is also 4 EC. In this course, the industrial chemistry, we teach, me and a colleague of mine, Hitt, on the industrial processes that are currently in the chemical industry. For example, in the refinery, we teach how to do the naphtha cracking, but also thermal cracking and We teach on gasification, the Haber-Bosch process, Fischer-Tropsch, etc. We picked the most important processes in the current industry. And for example, for naphtha cracking, we also look towards the future. Do we crack naphtha in the future? Well, maybe we want to first pyrolyze our waste plastic, and then the pyrolyzed waste plastic is fed into a naphtha cracker. And what are the requirements to do this? And where do you have to be careful for? And for example, is there any chlorine or any bromine in there? Brominated hydrocarbons will result in HBr. They will eat your cracker from the inside out. So those are things that are included in our industrial chemistry course. And in parallel, we teach a project on sustainable industrial chemistry. And this project aim is mainly to make a sustainability analysis. And we do a social and an ecological life cycle assessment. And my colleagues, Laura Franco Garcia from the Behavioral and Management Sciences, have helped me to develop a social sustainability analysis tool where we do a stakeholder analysis. And for the ecological life cycle assessment, I use a commercial tool where we get a free academic license every year. And with those tools, our students, they learn how to evaluate for example, the impact of synthetic diesel and kerosene. And so what they have to do is they have to build themselves a gasification plant. And for example, gasify hemp, because the active ingredient of hemp is only the top of the plant, and the majority of the plant is considered waste. Well, we can make fuel out of it via gasification, followed by Fischer-Tropsch and hydrocracking. And so also you can do waste plastic, as mentioned. And some groups, they work with coal, and other groups work with biogas. And the nice thing is, among different groups, you can also compare the impact of the different types of feedstocks. And then this year, for example, the functional unit of the evaluation was to do a holiday in Portugal. And so they have to calculate what is their impact if you do that with traditional fossil diesel and compare it with synthetic diesel, for example. Well, this is how we embed sustainability in our bachelor. Let's look into the master now. We have a 2-year master curriculum, where in the first year we have the courses, and in the second year we have an internship and the master assignment. So 3 months internship and some 8 months, 7 to 8 months master assignment. We have 3 specializations here. We have chemical process engineering and molecules and materials engineering, the same as mentioned before. We have a third one that is a bit more towards inorganic material science. And of course, here for today, chemical process engineering is the central topic. That's also where I am active in. We have 32.5 EC compulsory courses and 27.5 EC of electives. And my own course is Advanced Molecular Separations. And let me give a quick highlight there. The process and plant design, that is 15 EC. That's a very large course where also, let's say, flow sheeting and including also flow sheeting for separations is involved. But for my Advanced Molecular Separations, which is just a 5 EC course, I recap what should be on the bachelor level known, what is the starting point for my course, then discuss about molecular properties and thermodynamics. We do distillation topics. We do liquid extraction topics, including liquid extraction with immobilized solvents, for example. And in all the processes that I teach, we work from molecule to process. We let them develop a process. And where I was taught when I was a student that there are 3 things of importance for a chemical engineer: money, money, and money. Nowadays, what we teach our students is that what is very important is the sustainability of your process. So we ask them in groups of 4 to work out case studies and to really evaluate the impact also there. And this is mainly then energy-wise, how much energy is used for the separation or the separation train that you develop. And so this is also a topic where we see that the sustainability related topics come back. For example, we deal with heat pump assisted distillation, and I teach our students based on a diagram of an ideal binary distillation. And when is distillation intrinsically inefficient? That's here and here. And when is the internal efficiency reasonably well at 70%? This is also for a very low relative volatility at equal molar feed. And then the distillation can be done with a heat pump. But if you are in the asymmetric feeds here and here, then definitely you would like to go for a membrane process, a solvent-based process, such as extractive distillation or liquid-liquid extraction. We also deal with bio-based solvents in Twente, and these are topics I do in my research, and I let it also come back in the teaching. These are actual transition technologies, but as mentioned, we have a full program, and we have a limited amount of time. And so we can only teach so much about heat pumps. I teach them about heat pumps, what a few different types that are available, but I don't go very much in detail how these heat pumps actually work. And that is more for a third cycle, or maybe also potential for lifelong learners. Now, in the PhD program in the Netherlands, this is a 4-year program, and next to doing a lot of research, of course, our students have a mandatory course load of 30 EC, out of which 15 are mandatory courses, such as publishing in English and presenting and supervision of students. And there is also 15 EC in specialization courses. And these specialization topics that can be very interesting options to teach about transition technologies. Now let's have a look in transition technology. What is a transition technology? In my opinion, transition should mean that we go to a circular and bio-based economy. We try to cycle 80% of our materials, and we realize that we cannot be 100% circular. You always have a loss, and that should be made up. So ideally, that would be made up by either bio-based source or directly from carbon capture to convert carbon via methanol and methanol to olefins and a lot of different routes into new materials. And so what is needed for this is recycling technology to be able to make the recycling work. For example, this includes separations, but also depolymerization. Do you use olefins for polymers, or do you use condensation polymers? These result in different types of recycle strategies. And both of the approaches, they need to be evaluated and they need to be known. So if you teach an engineer from the industry or a third cycle student on recycling technologies, this should be included, in my opinion. And above all, the technologies that you apply, they need to be sustainable. So if you use a solvent-based technique, it's essential that you also pick a solvent that itself is also sustainable, as much sustainable as possible. And so a few topics that I think should be part of transition technology teaching for third cycle and industrial engineers. Electrification of the chemical industry. Where in our industry can we apply electrification? And not everywhere it is as straightforward as can be, but there are certainly areas I mentioned already, distillations, where the top temperature and the condenser temperature is relatively close to the reboiler temperature. And if your feed is equimolar, then definitely you can apply a heat pump to reduce maybe 70% of the utility demand. Now, how to go bio-based and circular, that is another aspect. Topics that are really of importance is the production and recycling of batteries. I mentioned in one of my opening slides that we really need to go for recycling 90% of the batteries in order to limit the amount of primary mining that we need to do. It's also electronics. We have a lot of electronics, And it's very important. The Green Deal in Europe, whatever is remaining of that, is currently one of the aspects that is really, really important is that we, as a Europe, are autonomous or become autonomous and not so much dependent on factors outside Europe that we cannot control if we really want to be secure of our supply. And that means that most of our metals, of our rare earths and other rare elements, we should recycle, and we should develop recycling strategies. Now, if we look in terms of the EFCE, I could think, for example, for recycling of batteries, that crystallization is an important factor, because you would recycle the metals like lithium and cobalt as a salt. So you would recover them maybe with a liquid extraction, but then you would do a crystallization. This means that we are dealing with solids. Also, mechanics of particular systems is of importance. So I see easily here 3 working parties with specialists available in Europe that could play a role here, and probably many more. And one other example that I'm also giving here, going bio-based and circular. If we have bio-based polymers, polymer reaction engineering appears to be a working party with specialists that can help us there. Process intensification, one of the things is very important. Bio-based is naturally not such an easy approach. And drill a hole and get oil out of the soil is much easier than to have a biorefinery. And so in order to have the biorefinery somewhat competitive, we really need to include process intensification. And of course, in all the situations, thermodynamics and transport properties are important. And so we can see that with all our transition technologies, we can pinpoint very specific aspects of these transition technologies that are related to our working parties. And I have reached out as a scientific vice president of the EFCE to the chairs of the working parties and asking them also, please think about what technology in your field is really a transition technology. And then we may want to consider, do we develop specific courses for third cycle students and for our industrial engineers to become trained in these areas? This is a process that has just been started up, and we are working on this. In the Netherlands, I have my ISPT hat, and you see I found a hat with the bee from Boelo. Of course, this is from the time that I was working at MIT, and the local baseball club also had a bee. These 3 hats of mine, university professor, program director at ISPT, and being a member of NPT and working at the EFCE together with 20 working parties and 7 sections, this allows me to try and set up courses. I realize there are already in our working parties a lot of courses. Many of our working parties organize summer schools or other events where PhD students can receive a training. And these, I think, we could emphasize even more. And what we can do is also look at what are we teaching there. Can we specifically address sustainability issues? And I think the lifelong learning is a very important aspect. I have here, this is a qualitative curve. I did not specifically count all the engineers in the field, but what is important, the third cycle students that we have, they are only here, they are in the beginning. We have a lot of engineers that are of middle age, maybe my age, mid-40s or 50s, that maybe in our training many years ago, we were not trained in all the transition technologies. So I think we have a key opportunity here to set up these courses and involve the working parties and sections, because there we have the specialists and they can help us set up slide decks and think about what are the key technologies towards the transition. Now, running ahead, I've already started to do a pilot in the Netherlands together with ISPT and, of course, the Netherlands process technologist. We start with the biorefinery course that is in December, 9, 10, and 11 of December in Eindhoven. And I'm talking with Tony Kiss, that is the distillation expert in the Netherlands, the academic distillation expert, I have to say, because we have a lot of industrial experts as well, of course. I'm discussing with him to teach heat pumps in distillation and dividing wall columns in distillation. And we aim to have that course in the midst of January. And I'm also aiming, just like the link here on the biorefinery course, to have that link for the distillation course available in the next few weeks so that you can enroll for this course as well. And these are examples. But what I really hope is that over the course of time, we will have from the working parties that the members of the working parties, each in their own country, could set up a course. And of course, you can also do it internationally to organize a summer school that is accessible for all kinds of attendees from different countries. This was what I have to present. Thank you very much for your attention. And I am open for discussion, questions. Thank you.
So thank you. Well, for the presentation, it was really comprehensive, and I like also some introduction of the two courses that you will organize in December and January. That's especially important for the practicing industrial engineers also. So it's I appreciate that. So far, we have no questions. So anybody from the audience, or we already have some question, but before I start reading the first one and second one, I will maybe pose one question myself. Of course, chemical engineering is one of the many engineering professions, and sometimes we have to face boundaries with other engineering professions. So what would be your opinion on shall the chemical engineers have some knowledge about how the electric grid operates? Because for electrification of the industry, we should have some understanding of the available electricity, or about, let's say, land use. That means how much land is available, and it limits the amount of biomass that we produce locally. About logistics of some recycle streams and collecting batteries. We already recycle more than 99% lead acid batteries, nickel, cadmium. Regarding the lithium ones, the large batteries are going to be recycled almost completely. The small ones in consumer electronics, not that well, of course. So shall we also step with some knowledge and introduce it to chemical engineers, or shall we remain like plant-based, as you shown in your examples of your subjects? That means really focus on chemical plants and processing. That means to the core competencies of chemical engineers. So what would be your opinion on that?
Yeah, so partially these subjects are included already in my course. We do a life cycle assessment, and the life cycle includes also, let's say, the supply of materials and energy. But to go in the details of how an electricity network works, that is maybe a bit far. On the other hand, if you want to transition, and what we aim for the Netherlands is to have 92 gigawatts wind energy on the North Sea. Yeah, I think it is essential that you realize that if there's no wind, there's no power. And if you have a lot of solar panels, well, unfortunately, in the Netherlands, the sun is not every day shining. Yeah? So we have to deal with flexibilization. We see that, for example, companies in the Netherlands that use already a lot of electrochemical power. And that there's a salt winning company that has a contract with the grid that they use. They work only at 90% of their capacity, and the remaining 10% is for the grid. The grid owner as a flexible source. So if there is a surplus of energy available due to a lot of sun, then they can ask the company to increase their production, or if there is a shortage, they can also ask them to reduce again a bit. And so this will require a basic knowledge of how a grid works, but I don't think that you need to be a very detailed grid engineer.
Okay, thank you. Maybe I will switch now to the questions from the audience for the answer. The first question is from Simon Pino, and I will paraphrase maybe the question just to short it up. In the first part, it's mentioned, of course, the importance of recycling of all the metals, and then it said that, well, we recycle as of now much less percentage in plastics, but it was mentioned in your presentation. So I will skip to the important part of the question, and it's how shall we approach in teaching transition to something which is called transition and integrate the degrowth. Probably it's meant that in the future, in case if electric vehicles are successful, then the refineries, the classical refineries processing crude oil, probably will reduce their capacity. And that means that portfolio of their raw materials will be not just crude oil, but maybe biomass, maybe some waste, and also the production capacity of fuels, whether fossil-based or synthetic-based, may be decreased. So shall we teach also some of these like strategies, not just how to make a better intensification and better efficiency, but how to prepare for this really shaking or possible shaking of the industry? That means the growth, that means shrinking of some of the refineries.
I do think that is very important, and to some extent I already do this because one of my lectures in the industrial chemistry and processes course is about mineral acids, sulfuric acid and nitric acid. And sulfuric acid nowadays is made from sulfur that comes from the oil industry, where in the past you had ores. If you are diminishing a lot, let's say the demand for fossil diesel, you also have a lot less desulfurization process, and there is less sulfur available for making sulfuric acid. That would mean that you would have to go back to mining maybe if it is really, really little. But of course, that is on the long term. But this is a topic that I do address. So I always ask the students, hey, where do you think the sulfur is coming from? And of course, in the beginning, they don't know it's coming from the oil, but these links, they should be included. And this is exactly what I love about the course, is that you are able, because you teach Haber-Bosch gasification, but also the oil refinery and mineral acids and polymerizations, and high density polyethylene, low density polyethylene, etc. You can make these cross connections between the different industries. It's really not standalone factories. If you change one factory, if you change, let's say, the resource to product chain of one factory, it impacts also the other factories. And that is, I think, one key aspect that we should not forget to teach.
Yes. So first, all these questions, they are not mentioned to be offensive against you, that you don't have something in your course, or so. It's just generally the opinion what shall we do have. So there is another question from another participant, which is Naila Even from, I guess she's from Toulouse, and she asked, shall we include in the teaching also account for the risk? I mean, the risk mentioned by IPCC, that International Panel on Climate Change, that means what happens if there is really more than 2 degrees centigrade temperature rise, what are all the consequences and possible disasters and so on with respect to availability of some sources. That means reflecting all the geopolitical movements and all the big risks. So shall we? Of course, the time in teaching when the curriculum is limited, and it's probably impossible to really approach all details and so on, but generally, shall we introduce the basics of what is the mechanism of climate change and what are the impacts, and explaining from the technical perspective, so why we do all these things related to sustainability?
Yeah, I do think that that is important, indeed. Yeah, yeah. And just to get back to my own course on sustainable industrial chemistry and processes, I asked one of my colleagues who is a specialist in carbon capture to give a CO2 lecture. And in that lecture, he spent some time, it's just one lecture, but in one lecture, you can show what is the impact of the CO2 emissions and what are results of that. We don't go into full detail on local levels, but we do express that situations like we currently have in Spain with an excessive rainfall, that these are most likely related to the changing climate. Yeah.
Oh, thank you. Maybe Professor Piero Salatino may have a question.
Yes, you're right. Boelo, thank you for your presentation. You went into detailed aspects which are quite instructive, and it's nice to see the difference between our words, the Italian and the Dutch word, which I could have perceived in the past. I have two small remarks. First of all, this comes from my very personal sensitivity. There seems to be, in general, a bit of emphasis on the role of recycle. I mean, there is the perception of circularity to be just a fully circular process, which most typically does not consider the fact that we are living in a growing world. The growth rate of primary production of aluminum is somehow between 5 and 7%. The current growth rate of lithium primary production is around 13 to 15%. This brings immediately to the point that recycle may only limitedly contribute to sustainable use of resources, whereas the attention should be shifted to the stock management, to avoiding the piling up of materials, which seems to me a missing point in most of our teaching moduli on sustainability. What is your perception of this? Metals are extremely, apart from lead, which is probably the only major economy, all the other metals are extremely quickly expanding. And then I would like you to know, is this something which is worth declaring, is worth bringing to the attention of our students?
Yeah, certainly. I think that that is important. But the reason I put emphasis on the recycling is exactly because I think if we do not do the recycling, you would need even higher growth rates, which are definitely not sustainable. This is if we do not start to recycle properly, or maybe we already started somewhat, but we should really ramp up the rate of recycling in order to avoid that the stockpiling needs to go through the roof. I think that both aspects are maybe of equal importance. Yeah.
And the other point is lifelong learning. You are absolutely right. I liked very much one of your last slides. We are talking to students for 5 years, 3 years, and then their lifetime will be, professional lifetime will be some 40 years, 30 years or so. Is there, in your experience, any systematic way to promote lifelong learning, apart from a voluntary? In Italy, we don't have. This is clearly a lack. This is clearly something missing. What is your perception? Because I think we should be increasingly involved in assisting our students well after their academic experience.
Yeah. Yeah, in the Netherlands, we also don't have it. I try to do it now with the Institute for Sustainable Process Technology combined with the Netherlands Process Technologies, so that the members of both organizations, these are different organizations. The ISPT has companies as members, and the NPT has individual engineers as members, but both of them, the employees of the companies or the individual engineers, they have access to our courses, and we hope that we gain a bit of momentum that people are really entering. I think one example of one of our member associations that has already a very good structure is the ICME. Yeah, ICME has the chartered engineer, and I think that maybe if we really want to proceed, we could have a look whether it would be feasible or desirable to include chartered engineering in a wider range over Europe, and then to be able to work as an engineer in the industry, you would have to be chartered, and being chartered could mean also that you have an annual update, a certain number of courses that you need to do in a 5-year period, for example. Yeah, and that could include also transition technologies.
Thank you.
Mm-hmm. Thank you. So we have normal questions from the audience. So first of all, I'd like to thank all the audience. We still have more than 40 participants from the audience presented, so which is good. And I guess that to wrap up a little bit the discussion, that everybody who attended more or less agrees that it's important, education, sustainability, addressing these issues, exchanging experience. But typically, if somebody attends, people want to bring some take-home messages. So could all the speakers summarize, like, what would be your like message for let's say teachers or maybe industrial engineers attending? What are the critical concepts we shall teach either the students or practicing engineers? I mean, either the knowledge or the skills. So what would be like simply stated like message of all the speakers? Maybe we can start with Professor Salatino, because you were the first speaker.
Yes, probably if I should, from my sensitivity, my experience, summarize and in a very short take-on message, we should, we chemical engineers and the teachers in chemical engineering should go out of our comfort zone. We should be ready to face with systems engineering on one side and the molecular and I want to further underline biology is well within our field. So biology and molecular sciences and formulation science and engineering. This is not to be done by everybody. Everybody has to find his own vocation, his or her own vocation. We have to get the breadth and the richness as a community, not as individuals. It would be impossible to cover everything as an individual, and we have to stay connected. So this is the reason why we have EFCE, this is the reason why we have our associations, in order to provide also occasions like this. We have to do this. It's not just a matter of personal satisfaction. This is what the society is requiring to chemical engineering. And at the same time, we have to keep some identity. We don't have to lose our common language and the ability to interact in an effective way with each other. This is the challenge we are facing, and this is the challenge that we have to undertake every day.
Thank you. Maybe I will ask the same question as second speaker, who was Professor or Dr. Hitt, on the toolkit. So what would be your take-home message for either, because you were focused mainly to the educators, that means to the professors and the teaching. So what would be your like take-home message for somebody who was, let's say, not teaching yet sustainability and would like to include it in the curriculum? That means what would be like the most important take-home message from you?
Yeah, I would build on what Piero was just saying in one respect and say, yes, get out of your comfort zone, perhaps even further, and talk to the humanists and social scientists, and have the humility and the openness to say, I don't necessarily know how to do this, see someone who's doing something that you admire, ask for help or collaboration. And the main message that I would give is act. Do something, change something now, tomorrow. The resources are there for you to do it. The support is there. Maybe it won't go perfectly the first time, but that's okay. We're supposed to be teaching our students how to fail safely, try again. We're learning lifelong learning, right? We're learning alongside our students, and we can model that, I think, as well. So I would say, just try and do something.
Thank you. So it's a great message. We are learning with our students. That's exactly what I also think. And the same question also for Professor Boelo. Schuur. That means some take-home message from you.
Thank you, Professor Kosek. Yeah, I fully agree with the previous two speakers, and I was also going to say about SELCA, the social and ecological life cycle assessment. I did not do that on my own. I always joke to my students, I'm an engineer. I'm maybe not such a social guy. So we have social scientists that help us with that. But on top of that, there's one very important message. You introduced me with my inaugural lecture last week. The title of that lecture was "Let's Transition Together." And my main message there was we have activist students and employees in universities that want us to break ties with the chemical industry. And I think that everybody has their role in society, and I value activist people because they want to change things. But one thing I am really sure about is if we break ties with large industries, our transition will be delayed with a couple of decennia. Yeah, so we really should do this together, and that is what I try to teach our students, and I hope that other professors will also teach their students, because that's really important, I think.
Maybe from your answer, you mentioned the importance of social assessment, and that's something quite perhaps new to many of the chemical engineers, and especially the metrics of such a social assessment. We understand, let's say, environmental assessment, some business type of assessment, and so on, technical assessments, but let's say the metrics of the social assessment. Can you a little bit comment what's really included, because that's something not that well known to everybody?
Yes. So as the social assessment, as how we teach it, it is a stakeholder analysis. And I give always a very personal example. I say, well, if I exchange my diesel car, I don't have a diesel car anymore, but if I would exchange a diesel car for an electric car, my neighbors are happy because they don't breathe any soot anymore. But the people in Chile and in Bolivia that live next to the lithium mine, and they already have a water shortage. And so maybe for indigenous people in Latin America, the impact of my electric car is negative. And they are stakeholders. So the stakeholders are the neighbors of the factory. They are my neighbors. They are the employees of the companies. So if you consider where do we produce? Do we produce in Europe with European labor laws, or do we import materials from countries outside Europe? Is our, let's say, our resource to product line, is that transparent? Do we know what's happening? And are the companies where we source our materials from, are they behaving properly for both their employees and their neighbors? I think those are aspects of social sustainability that we really need to consider. And hopefully one other important, that not only we need to connect with the industry, but we should also connect with lawmakers, because if we do it purely on an economical basis, we see that we have big troubles. Currently, many plastic recyclers go broke in the Netherlands, and I think in Europe, because there is no regulation of how much recycled plastic need to be incorporated in products. And we get swamped by very cheap polymers from Eastern Asia, and they are basically pricing our European companies out of the market. And if we just force everybody that is producing to incorporate, maybe start with 25% recycled plastic, into fresh products, then it is really a law-enforced sustainability step.
Mm-hmm. Oh, thank you for this opinion. Of course, there are a number of things are always open to discussion. Maybe to wrap it up a little bit from my side of the sustainability session of EFCE. Of course, I understand that we should not reinvent the wheel. We today had three great speakers with a lot of experience in education sustainability. So we will probably organize, at least from my point of view on the action list, just a link to your resources that are already available there. That means we shall probably not repeat the work of others because it's already there. It's excellent, and as the point where people can just click and come not just to the pages of the three speakers today, but also to other teachers that I know from Europe who are also active in this field. Maybe I will give the word also to Dr. Hermann Feise for his final remarks.
Thank you, Juraj. Thank you again to all the speakers for a very thought-provoking morning. And we really covered a lot of the scope of what sustainability means and how many dimensions it has, way beyond what Boelo started out with money, right? Nevertheless, let's remind ourselves of what you said in your last sentence. If you go bankrupt, if the recyclers get pushed out of the market, that's not sustainable either, right? We have to remain in the market to be sustainable. I believe this has been a good step forward for sustainability and for education. Thank you all for doing that. Thank you to all the people in the audience who've listened to us. If you're interested, you can revisit these presentations on the EFCE YouTube channel, probably in about a fortnight, because we first have to complete the Spotlight series before it becomes online. I wish all of you a very successful remaining Wednesday, whether it is an evening in Asia, a morning in the US, or just the afternoon here in Europe. Tschüss.
Cheers.
So, goodbye.
Bye-bye.
Bye.
Goodbye.